हेलो डियर स्टूडेंट्स, वेलकम टू एग्जाम दोस्त। कैसे हैं आप सभी लोग? तो जल्दी से कनेक्ट हो जाएंगे। आज इस सेशन में फिर से हम कम्युनिकेशन सिस्टम्स के इंजीनियरिंग सर्विसेज एग्जामिनेशन के PYQs डिस्कस करेंगे। तो एक बार कंफर्म कर लीजिएगा कि आपको मेरी ऑडियो वीडियो सारी चीज़ें क्लियर हैं। ओके, मेरे रिकॉर्डिंग सेशन लाइव हो गया है और ठीक है, ऑडियो वीडियो सारी चीज़ें परफेक्ट है। चलिए, तो जब तक सब लोग कनेक्ट होते हैं, जस्ट मैं आपसे इन्फॉर्मेशन शेयर कर लूँ कि अगर आप गेट और ESE एस्पिरेंट्स हैं तो यहाँ पर एग्ज़ाम दोस्त पर आपके लिए सभी बैचेस अवेलेबल हैं। और अभी आप अर्ली बर्ड ऑफर ले सकते हैं EB30 कोड यूज़ करके। फ्लैट 30% फी वेवर आपको मिल सकता है। तो अगर आप गेट 2026 या 27 के एस्पिरेंट्स हैं तो आपको कोड यूज़ करना है EB30, और यहाँ पर आप संकल्प 2.0 जो 2026 का बैच है वो ऑप्ट कर सकते हैं ओनली एट ₹16,800। और जो 2027 एस्पिरेंट्स के लिए नीव 2.0 बैच है वो आप ऑप्ट कर सकते हो ओनली एट ₹26,000 प्लस 600 प्लस GST पे। अगर आप गेट प्लस ESE दोनों के लिए कॉम्बो कोर्स अगर देख रहे हैं तो फिर आप लाइव प्लस रिकॉर्डेड कोर्स के लिए जा सकते हैं। उसके लिए भी EB30 कोड यूज़ करने पर आप 30% फी वेवर के साथ ज्वाइन कर सकते हैं ओनली एट ₹18,200 प्लस GST में। और अगर आप नॉन टेक्निकल ESE गेट के साथ साथ चाहते हैं रिकॉर्डेड फॉर्म में तो 10,500 प्लस GST में आप इसको अवेल कर सकते हैं। ठीक है, तो चलिए स्टार्ट करेंगे आज के सेशन को। इससे पहले 2 सेशंस हमने यहाँ पर किए हैं और आपने इससे पहले ऑलमोस्ट 110-120 क्वेश्चंस अप्रॉक्स आपने कर लिए हैं कवर। तो रिमेनिंग क्वेश्चंस को आज हम देखेंगे। तो आप लोग सबसे पहले तो पेन पेपर लेकर के रहिएगा यहाँ पर, जो भी स्टूडेंट्स कनेक्टेड हैं। ठीक है, क्योंकि आपको सॉल्व करना है। जैसे हम बार बार बात करते हैं कि यहाँ जो क्वेश्चंस होते हैं ESE के, अगर आपसे बन रहे हैं तो विद इन 30 टू 40 सेकेंड्स आपसे बन जाएंगे। लेकिन फिर भी क्योंकि यहाँ पर मैं डिस्कस करूँगा, क्वेश्चन पढ़ूंगा, तो थोड़ा सा टाइम मुझे ज़्यादा लगेगा। तो आप लोग मीनवाइल आप आंसर कर सकते हैं, कमेंट्स अपने कर सकते हैं कमेंट सेक्शन में आंसर्स को। तो चलिए स्टार्ट करते हैं। सबसे पहला जो क्वेश्चन है, दैट इज द नाइक्विस्ट सैम्पलिंग इंटरवल फॉर द सिग्नल 700 सिंक ऑफ 700T प्लस सिंक 500Ts। तो बेसिकली इस टाइप के क्वेश्चंस आप सिग्नल्स में ज़्यादा करते हैं, लेकिन कम्युनिकेशन के भी PYQ में इसको आप कंसिडर कर सकते हैं। तो जब भी 2 सिग्नल्स एडेड हैं तो सिर्फ हमें ये देखना है कि इनमें से ज़्यादा फ्रीक्वेंसी किस सिग्नल की है, वही इस ओवरऑल सिग्नल की क्या होगी, मैक्सिमम फ्रीक्वेंसी कंपोनेंट होगा। And once as you have decided the maximum frequency component of signal x of t, then only you are going to decide its sampling frequency. So let's say it is signal x of t, which is given as sync of 700T plus sync of 500T. So sync of t is given as sin pi t upon pi t. Hence if you replace t by 700T, then sync of 700T will be equivalent to sin 700 pi t upon 700 pi t, which may also be written as 1 upon 700 times sin of 700 pi t upon pi t. And this signal can be compared with sin of xt upon pi t, because we know that for the signal sign of the form sin of xt upon pi t will have a Fourier transform that will have expandation in frequency domain from minus x to x. So if you compare it with sin xt upon pi t, then the value of x is 700 pi. So the spectrum of this signal is going to be, with respect to omega, if you see, then spectrum will be from minus 700 pi to plus 700 pi radians per second. And if the constant coefficient would be 1, then the transform will have a magnitude of 1. But as you can see here, the coefficient is 1 upon 700. So the transform will be 1 upon 700. Will have amplitude of 1 upon 700. So for this part, you have seen the Fourier transform. That is, the Fourier transform is expanded up to the maximum frequency component of 700 pi. Similarly, if you see the Fourier transform of sync of 500T, then this sync of 500T, it can be written as sync 500T. It can be written as 1 upon 500 times sin 500 pi t upon pi t. And hence its Fourier transform will be from minus 500 pi to plus 500 pi. So if these two signals are added in time domain, then overall maximum frequency component will be 700 pi. That is from the Fourier transform of this part, sync of 700T. So as you have now decided the maximum frequency component, that is in radian per second, so omega m, that is maximum frequency component for this signal, is 700 pi radians per second. So if you decide the frequency in hertz, then the maximum frequency in hertz is, therefore maximum frequency component is 700 pi upon 2 pi, that is equals to 350 hertz. Therefore sampling frequency must be, if you are going to find the maximum sampling interval, so the minimum sampling frequency will be fs must be greater than or equals to what, twice of fm. So minimum sampling frequency is twice of fm, that is equals to 700 hertz. Therefore sampling interval Ts, that is equals to 1 upon fs, it is going to be 1 upon 700, and as it is the value of time, so the unit is second, and accordingly option C is correct. 1 upon 700 second is correct for this question. So yes, Ravi, your answer 350 is correct for the maximum frequency component, but as you have to decide the sampling interval, so you have obtained the Nyquist sampling frequency first, then you have taken 1 upon fs to be the sampling interval. Moving to the next question, which one of the following system gives the highest figure of merit, a measure of the noise performance? So if you see figure of merit, that is signal to noise ratio in the output to the signal to noise ratio in the input. So for different cases, like for SSB, figure of merit is equals to 1. For DSB, for DSB-SC, figure of merit is 2. Therefore, DSB-SC is considered to be 3 dB better than SSB-SC, as if the noise performance is considered, because it is 2 times, figure of merit is 2 times, and in 2 times in dB it is equivalent to 3 dB. So DSB-SC is considered to be 3 dB better than signal SSB-SC. In full AM, if you see figure of merit, then it is given as 2 times K square M square T upon 1 plus K square M square T average. So if you see here, figure of merit is maximum value, it has maximum value of 2. In case of narrow band and wide band FM, figure of merit is given as 3 by 2 M square, 3 by 2 beta square. In both the cases, figure of merit is 3 by 2 beta square. But for narrow band frequency modulation, beta is less than 1. And for wide band frequency modulation, beta is very much greater than 1. So if you see, if we have asked for the maximum highest figure of merit, then the highest value will be considered from this one only, that is from wide band frequency modulation, because these two are same if you consider the formula, but the value of beta is very much greater in this case. So the maximum value of figure merit will be in the case of wide band frequency modulation. Therefore the correct answer is option A. I hope you can understand the solution. Next, if the number of bits per sample in a PCM system is increased from 8 to 16, then the bandwidth will be increased by which factor? So if you see, in case of PCM system, bit rate is considered to be NFS, and bandwidth is equals to this bit rate divided by 2. So if you see here, bandwidth is proportional to n. That is, if you are going to change increase n by 8 to 16, that is, you are going to increase n 2 times. If you are going to double the number of bits in which the symbol is getting, you can say that if you see here, bandwidth is equals to RB by 2. So if you are going to increase n by, if we increase n dash is equals to 2n, then bandwidth dash is equals to what? Earlier, let's say bandwidth is RB by 2, that is NFS by 2. In the next case, bandwidth dash will be RB dash divided by 2, that is n dash fs divided by 2, that is 2n into fs divided by 2, and this nfs by 2 is previous bandwidth RB. Therefore, if you see, that is bandwidth is getting doubled. I think you can understand from here only. If bitrate is nfs, so if you are going to double the value of n, then bitrate will get doubled, and as the bitrate is getting doubled, so the bandwidth will also get doubled. Therefore, if you increase, if n is doubled, that is increased from 8 to 16, then bitrate and bandwidth both will also get doubled. I hope now it is very much clear. So option A is correct for this question. Is it clear? किसी को कोई डाउट है तो बता देंगे यहाँ तक. अगर n डबल हो गया, बिटरेट डबल हो गया, मतलब बैंडविड्थ भी डबल होगी, क्योंकि बिटरेट बाई 2 ही बैंडविड्थ है. अगर बिटरेट डबल होगी तो बैंडविड्थ भी डबल होगा. ठीक है, चलिए नेक्स्ट देखते हैं. So the next question is, in a PCM system a 5-bit encoder is used. 5-bit encoder is used. If the difference between two consecutive levels is 1 volt, then the range of encoder is. So if you are using 5-bit encoder, it means you are going to encode every sample in how many number of bits? 5 number of bits. So if this consecutive levels, difference between two consecutive levels, it means you can say that the resolution, that is the minimum step size by which two symbols will be differentiated. So if you are having 5 number of bits, so total number of levels will be what? 2 to the power n, that is equals to what? 32. Total 32 levels will be there, right? And if every level is having a difference of 1 from its previous level, so if you start from 0, then the 32nd level will be what? The levels will be 0, then 1, then 2, then 3, up to what? 32nd level will be 31. So you can say that the range of encoder is from 0, 1, 2 up to 31. Accordingly, option A is correct. Is it clear? सर बैंडविड्थ कभी कभी आरबी भी होती है. देखिए आरबी जब आप जैसे पीएम जब आप ट्रांसमिट करते हैं, पल्स एम्पलीट्यूड मॉड्यूलेशन, उस केस में अगर आप 1 पल्स पर सिंबल अगर ट्रांसमिट करते हैं तो वहां पर फिर बैंडविड्थ इक्वल्स टू आरबी होता है. लेकिन इस केस में पीसीएम के केस में बैंडविड्थ इक्वल्स टू आरबी नहीं होता. ठीक है, ये समझ में आ रहा है कि 5 हमारे पास 5 बिट्स हैं, तो 5 बिट्स में हम टोटल कितने लेवल्स हो सकते हैं? 32 लेवल्स हो सकते हैं. ठीक है, और हर बिट जितने भी लेवल्स हैं सभी दो लेवल्स के बीच का डिफरेंस 1 बिट 1 अगर है 1 वोल्ट का, तो अगर हम 0 से स्टार्ट करते हैं तो हमारे लेवल्स कहाँ तक जाएंगे? 0 से लेकर 32nd लेवल जो होगा वो 31 वोल्ट पर होगा. इसलिए 0 to 31 वोल्ट इज द करेक्ट ऑप्शन. ठीक है, चलिए नेक्स्ट ऑप्शन देखिए. नेक्स्ट क्वेश्चन, द मेन यूनिट्स इन अ पल्स कोड मॉड्यूलेटर आर. पल्स कोड मॉड्यूलेशन में क्या करते हैं आप? एनालॉग सिग्नल को पहले डिजिटल सिग्नल में कन्वर्ट करने के पहले सैम्पलिंग करते हैं, फिर उसकी क्वांटाइजेशन करते हैं. उसका क्वांटाइजेशन के बाद जो लेवल होता है उसको आप क्या करते हैं? एनकोड करके ट्रांसमिट करते हैं. ठीक है, तो सैम्पलर बिल्कुल होगा, क्वांटाइजर बिल्कुल होगा, एनकोडर बिल्कुल होगा, कंपैरेटर नहीं होता. जब आप पीसीएम सिस्टम की बात करते हैं तो यहाँ पर कंपैरेटर नहीं. ठीक है, अब आप ऐसा मत समझिए जैसे डेल्टा मॉड्यूलेशन में अगर आप गए तो डेल्टा मॉड्यूलेटर को अगर हम 1 बिट पीसीएम देखेंगे तो फिर डेल्टा मॉड्यूलेशन में कंपैरेटर है. लेकिन वहाँ पर अब जब यहाँ पर पीसीएम पल्स कोड मॉड्यूलेशन की बात कर रहे हैं तो कंपैरेटर नॉर्मली आप यहाँ पर अवॉइड करेंगे, और उसके अकॉर्डिंग 1, 2 एंड 3 ये आपका ऑप्शन करेक्ट होगा. दैट इज ऑप्शन सी इज करेक्ट. ठीक है, अगर 1, 2, 3 एंड 4 होता तब हम डेल्टा मॉड्यूलेशन को कंसिडर कर भी सकते थे, लेकिन यहाँ पर वैसा ऑप्शन भी नहीं है. ठीक है, चलिए नेक्स्ट देखिए. ओके, नेक्स्ट, द डिस्क्रीट सैंपल्स ऑफ एन एनालॉग सिग्नल आर टू बी यूनिफॉर्मली क्वांटाइज्ड फॉर पीसीएम सिस्टम. If the maximum value of the analog sample is to be represented within 0.1% accuracy, the maximum value of analog sample. See, यहाँ पर क्या बोला जा रहा है आपसे, ठीक है, पहले एक बार मैं पूरा क्वेश्चन पढ़ देता हूँ. देन minimum number of binary digits required will be nearly. See here in question what we are having is the discrete samples of an analog signal are to be uniformly quantized for the PCM, that is the usual process. First we'll be sampling the signal, analog signal, then the samples will be quantized. So whenever you are going to quantize any sample, then there will be some quantization error, and that maximum quantization error is what, if you see here, then you know that maximum quantization error is equals to what? Step size by 2. If we are talking about the magnitude of maximum quantization error, because quantization error is distributed uniformly between minus s by 2 to plus s by 2, you know that. So it is going to be a step size by 2. Now what you are having in the statement here is that this error must not be greater than 0.1% of the maximum value of analog sample. So if you are having any, let's say any periodic signal which has amplitude AM, then the maximum value is AM amplitude, and the peak to peak variation, because if you have to find the value of step size, then step size is what? Step size S is equals to V peak to peak divided by total number of levels in which you are going to get you are going to quantize the signal. So V peak to peak upon 2 to the power n will be the value of step size. So if maximum amplitude is considered, then the step size is what? Let's say you are having a signal which is varying from minus AM to plus AM. So it is minus AM, it is plus AM. So V peak to peak value is twice of AM divided by 2 to the power n, and you have to find the value of n such that this given condition will be satisfied. So it is 2 AM upon 2 to the power n. It is the step size. The value of step size is 2 AM upon 2 to the power n. Therefore, maximum error is what? Maximum error magnitude. If you see magnitude of maximum error, then it is going to step size divided by 2, that is 1 by 2 times twice of AM divided by 2 to the power n. This 2 and 2 will get cancelled, and you will be having AM upon 2 to the power n. Now it is given that this error must not be what? If the maximum value of the analog sample is to be represented within 0.1% accuracy, means it is given in the question that this maximum error must be less than 0.1% of this AM only. Therefore, from the given condition, this maximum error, which is AM upon 2 to the power n, it must be less than or equals to 0.1% of AM. That is, you can also write AM upon 2 to the power n must be less than or equals to AM into 0.1 divided by 100. So if you see here, AM and AM will get cancelled. It is 1 upon 2 to the power n must be less than or equals to, we can write it like 1 upon 1000. If you remove the decimal from the numerator, then there will be 10 in the denominator. So there will be 1 upon 2 to the power n must be less than or equals to 1 upon 1000. Or you can say that 2 to the power n must be greater than or equals to 1000. Must be greater than or equals to what? 1000. If you see here from this relation. So if you put n equals to 10, then it is going to be 1024. You know that 2 to the power 10 is 1024. If you are going to take n equals to 9, then it will be 512. So it means to satisfy this condition, as n must be greater than or equals to 10. So the minimum value of n is 10. So now if you see the options, 10 is missing in the option. 10 is not available in the option, but n must be greater than or equals to 10. So you will have to select the value which is greater than 10. Therefore 7 is not correct, 9 is not correct. 11 and 13 are going to give you the error which will be less than 0.1% of AM. But as the minimum number of n is required, therefore you will be going for option C, that is n equals to 11. So nearest possible option which is going to give you the maximum error of 0.1% of maximum peak value, it is going to be n equals to 11. Any doubt? Yes. Ravi, option C is absolutely correct. Very good. Next, a signal m of t that is 2 cos 6000 pi t plus 4 cos 8000 pi t plus 6 cos 10,000 pi t is to be truthfully represented by its samples. The minimum sampling rate using band pass consideration will be. See here, it is mentioned to use band pass consideration. So if you see here, this m of t is having three frequency components. From here, if you see, this 6000 pi t in radians per second. So the frequency of maximum frequency component of this signal is going to be 6000 pi divided by 2 pi, that is 3000 hertz. So this signal, this part of the signal is having maximum frequency of 3000 hertz, that is 3 kilohertz. Similarly, this part is having frequency in hertz, that is 4000 hertz, which is 4 kilohertz, and this part is having frequency that is 5000 hertz. So if three signals are added in time domain, so the maximum frequency component is maximum of these three, and that is going to be 5000 hertz. So if low pass sampling will be considered, then simply you can be writing that the minimum sampling frequency is twice of fm, that is 2 into 5000, that is 10,000 hertz. But here, as we have to consider the band pass sampling, so in case of band pass sampling, for band pass sampling, minimum sampling frequency f of s must be greater than twice of fh upon k and less than or equals to twice of fl upon k minus 1, where fh is maximum frequency component of the signal, maximum frequency, highest frequency, fl is lowest frequency or minimum frequency component, minimum frequency. This k is integer part of fh upon bandwidth, where bandwidth is maximum frequency component minus minimum frequency component. So you must be knowing all these results for bandpass sampling. So first we'll be calculating the value of bandwidth. If you see from this case, what we are having here is lowest frequency component fl is 3 kilohertz, 3000 hertz means 3 kilohertz. fh is maximum frequency component, fh is 5 kilohertz, 5 kilohertz. So the value of bandwidth b is fh minus fl, that is equals to 2 kilohertz. Therefore fh upon bandwidth, if you find this ratio fh upon bandwidth, so it will be 5 kilohertz divided by 2 kilohertz, that will be giving you 2.5. So maximum integer value of this ratio fh upon bandwidth, which is going to, actually it is not k, it is the value of n. N equals to integer part of fh upon bandwidth, and k is equals to 1, 2, 3 up to n. You can take the value of k from 1 to 3 up to n. And if you are going to take k value equals to k maximum, then you will be getting the minimum sampling frequency. So to have the minimum sampling frequency, we will be taking the value of k, that will be k maximum. So from here, the value of n is equals to maximum integer part of fh upon bandwidth, that is equals to 2. So if n is equals to 2, then the value of k that are possible is k equals to either 1 or 2. Two values of k are possible. Therefore, k is equals to 1 or 2. K max is equals to 2. So you will be taking, for minimum sampling frequency, you will be taking the value of maximum value of k, that is going to be 2. So if you put the value of 2 and fh in this equation, then what you will be getting is fs must be greater than or equals to twice fh upon k to twice of fl upon k minus 1. For k is equals to 2, fh is equals to 5k, and FL is equals to 3k. Or you just have to calculate the minimum sampling frequency. So it is the value of minimum sampling frequency, because sampling frequency must be greater than this. So it is the minimum sampling frequency. Minimum sampling frequency. Minimum sampling frequency. Therefore, we don't need to calculate for this. Therefore, minimum sampling frequency, Fs minimum, is equals to twice Fh upon k, that is 2 into Fh is 5 kilohertz divided by maximum value of k is 2. Therefore, you are going to get 5 kilohertz as the minimum sampling rate if we consider the band pass sampling. If low pass sampling would be considered, then the value of minimum sampling frequency will be directly 2 into 5000 hertz, that is going to be 10 kilohertz. But in this case, what we have obtained is option A is correct. Minimum sampling frequency is 5000 hertz or 5 kilohertz. Is it correct? C option is not correct. For this question, C is not correct. Ravi, please recheck your solution. Next, if n signals are multiplexed using PAM band limited to FM, then the channel bandwidth need not to be larger than. See, in this case also, if you see, then PAM signals are transmitted using time division multiplexing, and in this case, if you are not mentioning, if you have not mentioned anything else, then what you will be taking is, for this case, n signals are multiplexed using PM band limited to FM. Every signal has a band limit maximum frequency component of FM, or you can say the band width of every signal is FM. Therefore, if you see here, bit rate, in this case PAM time division multiplexing must be using. So in case of TDM, bit rate is n into Fs, and if nothing is mentioned, then you are going to take Fs is equals to twice of Fm. So it will be, here n signals are multiplied, so it will be n into Fs, that is n into twice of Fm. So it is bit rate. Therefore, if n signals are multiplexed using PAM band limited to FM, the channel bandwidth need not to be larger than. So n into twice of FM is bit rate. Therefore, bandwidth is bit rate by 2, that is n into twice of FM by 2, and that is going to be n into FM. So the bandwidth need not to be greater than n into FM, that is option B is correct. For this case as well, option B is correct, that is bandwidth is no need to be greater than n times FM. Next, for a binary phase shift keying modulator with a carrier frequency of 70 megahertz, what you are having here is carrier frequency is given out to be 70 megahertz and input bitrate of 10 Mbps. Bitrate, you are having bitrate equals to 10 Mbps. So the maximum upper side frequency and minimum lower side frequency are respectively. See, if the data stream, let's say in time domain, the 1 and 0 binary data is represented by sync pulses, then in frequency domain their spectrum will be represented as a pulse of rectangular pulse, as a rectangular pulse. So if you see the spectrum of this binary phase shift keying, then for this spectrum, for the spectrum of this binary phase shift keying, it exists centered at carrier frequency, and the total bandwidth is going to be RB. That is, it is from FC plus RB by 2. It is, this point is FC plus RB by 2, and it is from FC minus RB by 2. So it is going to be the spectrum with respect to F. So it is going to be the lowest lower side frequency, that is LSF, and it is going to be the higher side frequency. So lower side frequency and higher side frequency, USF, that is upper side frequency, is equals to FC plus RB by 2, that is 70. It is also into 10 to the power 6. It is also in the terms of 10 to the power 6. So you can take 70 plus 10 by 2, that is 5, which is equals to 75 megahertz, and lower side frequency will be FC minus RB by 2, that is 70 minus 5, that will be 65 megahertz. And accordingly the option 75 and 65 is correct, that is option B is correct. So if that in time domain, if data sequence is represented by a sync waveform, then its spectrum is going to be what? It will be a rectangular one. So that rectangular spectrum spreads from FC minus RB by 2 to FC plus RB by 2. That is the total bandwidth of each of the pulses, what? It is equals to RB. So the upper side frequency and lower side frequencies are going to be 75 and 65 megahertz respectively. Moving to the next question. For an 8 PSK system operating with an information bit rate of 24 kilobits per second, the baud rate will be what? See, there are three things, that is bit rate. How do you define bit rate? It is, unit is bits per second, right? If we define for M array PSK system, here if you see for 8 PSK system, so for M array PSK system, or you can say that for a system which uses n bits for one symbol. Let's say we are having a system which is having n bits for one symbol. So n is having n will be having a unit, that is bits per symbol, right? So if you see, if you write it as RB, RB is bit rate, that is bits per second, transmitted bits per second. N is representing the number of bits in which each symbol is encoded. So n is bits per symbol. Then if you check the unit of, RB upon n, n is also known as n, it can also be given as n equals to log base 2m for M array system. If you are having an M array system, then using log 2m you can be relating the value of n. So if you use this formula RB upon n, the unit of RB of n will be what? Bits per second divided by bits per symbol, and it is going to be what? Bits and bits will get cancelled. This symbol will be in the numerator and second will be in denominator. So you will be having the rate, that is symbols per second. So this is known as the symbol rate or baud rate. It is known as baud rate or symbol rate. That is how many number of symbols are getting transmitted. Please wait for a moment. Okay, so what we are talking about is, if we have to find the value of baud rate or symbol rate, it means how many symbols are getting transmitted per second. So how can you find it? If you divide the value of bit rate, that is bits per second, by the value of bits per symbol, then you are going to get the value of baud rate. So baud rate, it can be written as baud rate, it is equals to RB upon log 2m. If you are not having n, then you must be having m, and here it is given that 8 PSK means you have given the value of m, that is equals to 8. So in this case, RB is bit rate, that is 24 kbps. For that I am writing into 10 to the power 3 divided by log 2m is log base 2 8, that is equals to 3. So it is going to be 24 into 10 to the power 3 upon 3. That will be given you 8 kilohertz. 8,000, that is 8,000 symbols per second. So it is 8,000 symbols per second. So it is the value of baud rate. So whenever you have to calculate the symbol rate or baud rate, then you just have to divide the value of bit rate by log 2m, or if you are having n directly, then you can divide RB by n to find the value of baud rate. Next, accordingly option D, C is correct for this question. Next, what is the maximum bit rate of a noiseless channel with a bandwidth of 1000 Hz transmitting a signal with 2 signal levels? So it is a direct formula based question on Nyquist theorem. So Nyquist theorem, you must be aware of. Nyquist theorem for noiseless channel says that maximum data rate or bit rate is equals to 2b log 2L. So you are having the value of bandwidth, that is 1000 Hz. So it will be 2 into bandwidth is 1000 log base 2. How many levels are there? There are only 2 signal levels. So log base 2 to the power of 2, that is going to be 2 into 1000 into 1, that is 2000. So bits per second, obviously it will be. So if the channel is noiseless, then according to the Nyquist theorem, the maximum data rate is going to be what? 2000 bits per second. Accordingly, option A is correct for this question. Next question is, a signal has 8 data levels with a pulse duration of 1 millisecond. What is bit rate? See, again here what you are having is, signal has 8 data levels, means it is the value of m. M is equals to 8. Pulse duration of 1 millisecond. If you are having a symbol which has a duration of 1 millisecond, that means symbol duration you are having. Symbol duration, that is equals to 1 millisecond. That means in 1 millisecond, how many symbols are getting transmitted? One symbol is getting transmitted. One symbol. Therefore, if you see, in 1 second, how many symbols are getting transmitted? Because it will be giving you the baud rate. Number of symbols per second if you have calculated, then it means you have calculated the value of baud rate. So to find the value of baud rate, if we are having that 1 millisecond is taken by each symbol, it means in 1 millisecond one symbol is getting transmitted. So in 1 second, how many symbols will be there? So it will be 1 upon 1 millisecond, that is 10 to the power minus 3, that is equals to 1000 symbols. So you can say that, therefore, baud rate, you have found the value of baud rate, that is equals to 1000 symbols per second. Symbols per second. And we have already seen that this baud rate is equals to RB upon log base 2m. So if you have to find the value of bit rate, therefore bit rate RB is equals to this baud rate multiplied with log base 2m, that is equals to baud rate is 1000 into log base 2. The value of m is mentioned to be 8. So it is going to be what? 1000 into 3, that is equals to 3000 bits per second, or you can write 3 kilobits per second. So it is option given in option C. So the option C is correct for this question. Is it right? Any problem? Ravija, other than band pass, then I am not getting your point. Other than band pass, if low pass sampling would be considered, then the minimum sampling frequency would be directly equals to twice of FM. In that case, if 5000 is the maximum frequency component, then sampling frequency, minimum sampling frequency would be 10,000. But in case of band pass sampling, we have used the formula. Next, consider the following statements related to the source coding. A conversion of the output of a discrete memory list source into a sequence of binary symbols is called source coding. Is absolutely correct. If you see here, a conversion of the output of a discrete memory list source into a sequence of binary symbols is called source coding. Yes, source coding you have, you must have read Huffman coding or Shannon-Fenner coding as the source coding, in which if you see, then the messages with least probability are getting encoded in the maximum number of bits, because messages with least probability has the maximum information. So source coding is mainly applied to encode the messages with highest least probability into maximum number of bits, and it is the process actually of the conversion of output of a discrete memory list source into a sequence of binary symbols called source coding. So option A is, that is statement A, is absolutely correct. Next one, the source code efficiency eta is defined as n equals to L minimum upon L, where L minimum is the minimum possible value of n, L is the average code word length. It is correct, but you may think that is not given the correct formula. What you have read is eta is equals to hx upon L bar into 100%. Normally this formula we use in case of Shannon-Fenner or Huffman coding, but it is only the value of L minimum upon L, because the theoretical value, it is the theoretical value of L minimum is equals to hx equals to L minimum. So both are same, both are theoretically the same. So this statement is, again, it is a correct statement. Next, if you see here, next statement is given as the code redundance gamma is defined as gamma equals to 1 plus eta. It is not correct. If you see here, then redundancy in the code redundancy is not 1 plus eta, it is 1 minus eta. Let's say efficiency is 80%, that is 0.10, then redundancy is not 1.8, it is going to be 1 minus 0.8, that is going to be what? 0.2. So third statement is not correct, and accordingly 1 and 2 only, that is option A is correct for this question, that is 1 and 2 only. Moving to the next question. A PCM system uses a uniform quantizer followed by a 7-bit binary encoder. The bit rate of the system is equals to this. What is the maximum message signal bandwidth for which the system operates satisfactorily? So we are having the value of bit rate. Bit rate RB is what? N into Fs. N into Fs, and for minimum, for satisfactory operation, what we can write is N into twice of Fm. So if we have to find the maximum message bandwidth, then for low pass signal, you know that bandwidth is nothing but the maximum frequency component of that signal. So if you have to find the value of Fm, then you just need to divide this RB. Therefore, if you have to find Fm, that is bandwidth of the message signal, then it is going to be RB upon twice of N. Values are given. RB is 50 into 10 to the power 6 divided by 2 into N is given to be 7. So 50 by 14, that is 3.571 into 10 to the power 6 hertz I am getting as this result. So accordingly option A is correct for this question. So these questions are very simple. You know why we are discussing all these questions? Because if you see the previous year pattern, then at least 40 to 50% questions in the ESE are going to be the repeated ones. Exact previous year questions are going to be present in the next examination. So you must be solving this question more than 5 to 10 times each of the questions. That if whenever you are having the same question in exam, then you just have the concepts as well as the almost you are remembering the answers as well. So you have to save your time as well, and there must not be any kind of error. So these questions are simple, but repeated solution of these questions will be better for you. That is, you must not be getting any kind of errors in the solution while you are taking the next examination. So do the previous year questions as many times as you can. It is going to be very much beneficial for you. Next question is, consider the following statements regarding digital communication. Digital signals can be coded to yield extremely low error rates is absolutely correct, and low fidelity. See, we have discussed fidelity in the last session. That is, it is the measure of how close the output is resembling to the input. That is, how exactly you are going to replicate the information at the receiver end. So in case of analog communication, if you see, then due to the continuous data transmission, fidelity is more. In case of digital, there will be a less fidelity, but it doesn't mean that you are not having your information. You are having your information completely, you can say very much fairly, but still you can say that the fidelity in case of digital signals, it is low. So the statement 1 can be considered to be true. Next statement is, digital signals next statement we are having is, digital signals are easier to encrypt for security and privacy. Absolutely correct. You can encode digital signals to have security. So, and the third one is, digital signal storage is expensive. It is absolutely wrong. Digital signal storage expensive is very much inexpensive. It is very, you can say, of low cost. So which of the following statements are correct? So option 1 and 2, statement 1 and 2 are correct. That is, option A is correct for this given question. Moving to the next question. Consider the following statements regarding time division multiplexing. TDM is readily implemented with high density VLI circuits. Definitely correct. TDM is a digital modulation technique, and definitely we can use VLSI circuitry. Next one is, TDM synchronization is less demanding than that of suppressed carrier FDM. See, this statement is ambiguous, because if you see, what we have to compare is which one is hard to implement. TDM synchronization is hard to implement, or suppressed carrier FDM is hard to implement. So if you see, then there is no clear explanation of this in any book or on net. But still, if you see, to match the options, TDM synchronization is less demanding is not correct, because in synchronization you have to be a commutator which acts perfectly and which connects the input and output side perfectly. That's why synchronization is not that much easy. If number of sources are so message sources are getting increased, then in that case synchronization is not very much easier. So you can say that this statement is not correct. TDM synchronization is less demanding is not correct. TDM synchronization is more demanding than that of suppressed carrier FDM. It is easier to generate suppressed carrier FDM than the time synchronization in TDM. It is more, you can say, more demanding. Next is, TDM crosstalk immunity does not depend on the transmission bandwidth. See, by crosstalk it means in TDM, that is intersymbol interference. If you see, then due to the lesser bandwidth, intersymbol interference will be increasing. So this statement is not correct. That is, crosstalk immunity does not depend on transmission bandwidth. It is not correct. If you are having maximum more bandwidth, then there is lesser chance of crosstalk, that is for intersymbol interference. So in that case, this statement is not correct. That is, crosstalk, we are relating crosstalk immunity with intersymbol interference in case of TDM. So as the bandwidth is increased, the crosstalk will get decreased. Therefore, it is not correct that crosstalk immunity does not depend on the transmission bandwidth. That is a wrong statement. And accordingly, if you see, only one is correct, is the correct statement. That is, only one, that is option C is correct for this question. Moving to the next question. During serial data transmission, a group of 512 sequential 12-bit data words is transmitted in 0.16 seconds. What is the speed of transmission? So you just have to calculate the speed of transmission. For this you have to calculate that how many bits are getting transmitted, and the time in which that much bit is getting transmitted is given as to be 0.16 seconds. So if you see here, there are 15 groups, 512 groups, and each group has a 12-bit data. Therefore, bits transmitted, total number of bits that are being transmitted is 512 into 12. Time taken is equals to 0.016 seconds. Therefore, speed of transmission, if you have to calculate speed of transmission, then it is equals to 512 into 12 divided by 0.016. So if you simplify this, you can eliminate the decimal from here. Now it will be 4 times and 4. So it is going to be 128 into 3 bits per second, and accordingly 384, so it is 384 kilobits per second. That is option A is correct. 384, here we are having 3 zeros, that is kilobit. We can write it as 384 into 10 to the power 3 bits per second. Therefore it is 384 kilobits per second, which is equals to given in option. Next question is, coherent FSK system is preferred over non-coherent system. See, this is an assertion reasoning type question, and the statement mentioned in the assertion is not correct, because we never prefer coherent FSK over non-coherent FSK, because it is not easier to generate the same phase and frequency carrier in FSK. So it is not correct. Assertion is not correct. If you see the reason, coherent FSK requires less power than non-coherent FSK. This statement is correct. This statement is absolutely correct, that coherent FSK requires less power than non-coherent FSK. This statement is correct, but it is not the correct reasoning. The correct reasoning is the simplicity that of non-coherent FSK is much simpler than the coherent FSK. So non-coherent FSK is preferred. But this reasoning is correct, but not for this assertion. So if you see here, then if A is wrong and R is correct, there is only one possible option, that is option D. A is false and R is true. Therefore option D is correct. So you just have to keep in mind from this question that which one is getting preferred. So non-coherent FSK is preferred over coherent FSK, okay? And this statement is correct, that coherent FSK requires less power than non-coherent FSK. Moving to the next question. Next question is, consider a binary humming code of block length 31 and rate equals to 26 by 31. Its minimum distances. See, if there is nothing else is mentioned, then you will have to go with the standard humming code. And in standard binary humming code, for standard binary humming code, it is a 1-bit error correcting code. Error correcting code. And for T-bit error correcting code, minimum distance D minimum is given as 2t plus 1. Actually, this t is given as d minimum minus 1 by 2. So if t is equals to 1, so if here t is equals to 1, it is t is equals to 1. T is equals to 1. It is a 1-bit error correcting code. So if you know the value of t, then d minimum will be directly d minimum is equals to 2 into 1 plus 1, that is equals to 3. So if it is a standard humming code, binary humming code, then in that case d minimum is going to be what? 3. So if you check whether it is a standard humming code or not, so you can check for these two things. That is, you know that for linear block code, there are some message bits, that is k number of bits, and some parity bits, that is r. So it is the total n bit block code. N. So this n equals to what? K plus r. Or you can write that k is equals to n minus r. Right? This n is equals to 2 to the power r minus 1. So what you are having is, consider humming code of block length equals to 31. So you are having n equals to 31 is equals to 2 to the power r minus 1. Also, it is k equals to n minus r. N we have written 2 to the power r minus 1. K we have written n minus r. Then data rate. What? Code rate. It is code rate, not data rate. Code rate. Code rate is equals to message bits, that is k, upon total number of total bits, that is k upon n. So this is known to be the code rate. So if you calculate for n equals to, if you are having total n bit n equals to 31, then you can calculate the value of r. So what you are having here is 2 to the power r is equals to 32. Therefore r is equals to 5. So if you see here, if r is equals to 5, then k is equals to, from here we have calculated n equals to r equals to 5, and k is equals to 31 minus 5, that is equals to 26. So it should be k is equals to, the value of k should be 26. Therefore the code rate is equals to k, that is 26 upon n, that is 31. So for if it would be a standard humming code, then the code rate according to the given condition, that code rate should be 26 upon 31. And if you see, then in question also it is mentioned that the code rate is equals to 26 upon 31. So as the given code rate is matching the code rate of standard humming code, therefore you can say, hence the given humming code is standard humming code. So if it is a standard humming code, then t is equals to 1, and hence d minimum is equals to 2t plus 1, that is equals to 3. Then we can say that yes, it is a standard humming code, and therefore d minimum is equals to 2t plus 1, that is equals to 3, and accordingly option A is correct. Is it clear? So it is the basic property of linear block codes, that is every block code will have total n bit, in which k bits will be of message and there will be some parity bits that will be represented by r, and n equals to total k plus r. Okay, next if you see, an MTI radar is operating at the wavelength of 5 into 10 to the power minus 2 meter, and the pulse repetition frequency is 1000. Then the first blind speed in milliseconds is occurs at. So you can directly use the formula, that is blind speed is Vn. We are asked to find the first blind speed. So you must you may be asked for second blind speed or third blind speed. So for first blind speed, we'll be taking n equals to 1. But in general, in terms of n, if we see the formula, then the formula of blind speed is Vn is equals to n into lambda into pulse repetition frequency divided by 2. For first blind speed, n equals to 1. Therefore, V1 is equals to 1 into lambda into PRF divided by 2. Lambda is given to be 5 into 10 to the power minus 2 and PRF is 1000, that is 10 to the power 3 divided by 2. So it is going to be 5 into 10 to the power 1, that is 50 by 2, that is equals to 25 milliseconds. So meter per second in meter per second. So it is going to be 25, that is option A is correct. Option A is correct. So you just have to remember this formula for blind speed. It is important. Next is, consider the following statements. If the maximum range of a radar has to be 4 times, first, the peak transmitted power may be increased 16 folds, and you are having such statements which will increase the range by 4 times. So if we consider the radar range equation, then maximum range R max, it is equals to Pt into G square lambda square sigma upon 4 pi Q into S minimum power 1 by 4. So it is the range equation, that is maximum range. For maximum range, here it is minimum detectable signal power is you are taking as S minimum. Sigma is radar cross section of target, lambda is wavelength, G is gain, and Pt is transmitted power. So if you see, the peak transmitted power may be increased 16-fold. As we are having 1 by 4 in the power, so if we have to increase range by 4 times. So what can be inferred from this formula is, for 256 to the power 1 by 4 is equals to 4. If you see, then 4 to the power 4 is equals to 256, right? So it means if you have to increase range by 4 times, then it is not sufficient to just increase the power by 16 times. If you take 16 to the power 1 by 4, it will give you 2. It means if you are going to increase power by 16 times, then the range will get doubled. Not 4 times, it will get doubled. Similarly, the antenna diameter may be doubled. If you see here, antenna diameter may be doubled. So this gain, this G is proportional to D square. G is proportional to D square. The sensitivity receiver, the transmitted pulse may be okay. So if you see here, you are having G square here. So if you will be increasing diameter, let's say D dash is equals to 2D, then in that case, G dash will be at the place of D. If you take 2D whole square, so it will be what? 4D square. Earlier, let's say it is D square. Then D dash is 2D D square. Therefore, G dash will be proportional to 2D whole square, that is 4D dash 4D square. So if you are going to increase the antenna diameter by 2 times, then gain will be getting 4 times. So if you see here again, see here, G is proportional to D square. So let's say initial gain is G. Then if D dash is 2D and here G square is there, so G dash, if D dash is 2D, then G dash will be 4G. G dash will be equals to 4G because it is proportional to the square of the diameter. So G dash equals to 4G. and you are having square of g here, so it will be 16 times. Again, if you take 1 by 4 power of 16, it means range will get doubled. So I am not writing the results, that is using this formula only. If you see the effect of these statements, if peak transmitted power is increased by 6 volts, R max will get doubled. Not 4 times, it will what? Will get doubled. The antenna diameter will be doubled. If antenna diameter will get doubled, again G square will be 16 times. Therefore, range, if we see the overall effect on range, then R max again will get doubled. Will get doubled. Not 4 times. The sensitivity of the receiver may be doubled. See here. If sensitivity is doubled, it means now we can detect the half of the signal power that have been detected earlier. Let's say you are having that, you are saying that in previous case, for this range equation, minimum detectable power is 4 watt. Let's say for an example, if we are saying that minimum detectable power is 4 watt. So if sensitivity will be doubled, it means now 2 watt can be taken as the minimum detectable power. As the sensitivity increases, the minimum detectable power will get reduced. So if sensitivity is getting doubled, then S minimum will get halved. It will get halved. So it is in the denominator. So if it is getting halved, it means what you have to do is to check the effect of getting the sensitivity doubled. This S minimum will be halved. It means the overall range will be 2 to the power 1 by 4. So the effect on range will be R max will be 2 to the power 1 by 4 times. It will be 2 to the power 1 by 4 times. Because it is S minimum, it is in denominator, it is getting halved. So the overall value will be 2 times numerator. This 1 by 2 will get into denominator, and that 2 to the power 1 by 4 will be there. So if you see here, and again the last statement, the transmitted power pulse width may be doubled. Which of these statements are correct? So if you increase the pulse width of the transmitted pulse by 1 to 2 times, then it will not be given directly to the, it will not be contributing directly to the Raja range equation. Therefore, it is also not correct. So if you see, then none of the options are correct for the range to be 4 times. If you see that it is not 4 times, if it is given to be 2 times, then in that case, option statement 1 is correct. That is, if you increase the maximum transmitted power by 16 folds, then the range will be 2 times. And if the antenna diameter is doubled, then again the range will be 2 times. So if you consider not 4 times, 2 times, then these two statements are correct, because there is no in none of the above is not available in the option. So you must have to select at least one. So accordingly, if you consider it to be 2 times, or you can say that the overall effect of these two statements, if you simultaneously you are going to increase peak transmitted power by 16 folds and diameter by 2 times, then overall effect of these two statements will increase the range by 4 times. So these two statements are correct. If we consider these two statements, these are wrong. Accordingly, option A is correct if we consider certain modification in the questions. Are you getting the points? Pulse width has not related. Pulse width is not directly related, right? Not directly related, that you cannot say that if pulse width is getting doubled, then transmitting power and then the range will be 4 times. It is not directly related. It will have some effect, but not as that much that the range will get 4 times. Okay. Next. A modulation technique in which the bandwidth of the modulated signal is extended well beyond the bandwidth of the modulating signal. Bandwidth of modulated signal is extended way beyond the bandwidth of modulating signal. As in case of AM, if you see the modulating signal bandwidth is omega m, then modulated signal has a bandwidth of twice of omega m. That is, it is related with the modulated, and the modulated signal bandwidth is related with modulating signal bandwidth. But here what we are given is, we have given that the modulated signal bandwidth is extended way more than the modulating signal bandwidth, independent of the modulating signal bandwidth. The modulated signal bandwidth is independent of the modulating signal bandwidth. So we have to select the correct statement, which type of modulation scheme it can be. So wideband modulation, extended bandwidth modulation, spread spectrum modulation, narrow band modulation. See here, if spread spectrum modulation is given, then you must have read the CDMA type multiple access technique, in which the spectrum, or you can say the spread of the spectrum, depends on code, not on the modulating signal. In this case, spread spectrum modulation, the spread of spectrum is determined by code and is independent of modulating signal. So this one is the correct option, that is spread spectrum. In spectrum modulation, the modulated signal bandwidth is independent of modulating signal bandwidth. Next, assertion is given as microwave links are generally preferred to coaxial cable for TV transmission. It is absolutely correct. Microwave links are preferred. And what is the reason of preferring microwave links over coaxial cable? Because coaxial cable suffer from these coaxial cables. It suffers from high frequency attenuation. And the reason being, it offers lower bandwidth. So as in TV transmission, we have to transmit audio plus video signal, which requires a large bandwidth. Therefore, to avail the larger bandwidth, we use microwave links, because you know that microwave frequencies are in gigahertz, and these offer 2 to 12 gigahertz bandwidth in some of the cases. So if you see here, microwave links are generally preferred over coaxial cable is correct statement, and reasoning is given as microwave links have greater bandwidth than coaxial cable. So both the statements are correct, and reasoning is the correct reasoning for the assertion. That is why microwave links are preferred over coaxial cable, because it provides the greater bandwidth, and for TV transmission we require a large value of bandwidth, so we prefer microwave links over coaxial cable. It means assertion A is correct and reasoning R is the correct reasoning for assertion, so we'll be selecting option A for this question. Next is, which one of the following statements is correct? For coherent detection of digital signals, the receiver must be, see again in this case also, for coherent detection, if you see, then receiver must be synchronized in phase. It is absolutely correct, this must be there, but time synchronization also is also essential, because if you when you study either ASK, FSK, PSK, or this type of band pass data sampling data transmission techniques, then in that case, if you see the coherent detection of digital signals, then in that case carrier must be completely synchronized, that is in phase, that is phase in frequency. In both the terms, the carrier must be synchronized. So synchronization is phase is absolutely correct, but there must be fair synchronization in time also. Then only the receiver will understand that this bit symbol is for which transmitted signal. But still, if you have to select any one of these, because the C and D option, if you see, then unsynchronized in time and phase is absolutely wrong, and unsynchronized, it can never be the option. So you have to select any one. Then the most appropriate option is synchronized in phase only. So it is also necessary. Phase and time synchronization both are necessary, but if we have to select any one of these two, then first we'll be going with synchronized in phase only. And accordingly, option B is correct for this question number 24. Next, if you see, in case of data transmission, which one of the following system will give the maximum probability of error? So it is a linear modulation technique. ASK is a linear modulation technique in which information is carried in amplitude, and noise can easily change the amplitude levels. So it is the maximum probability of error you will be getting in this ASK only. If you see probability of error, then probability of error for ASK, it is given as 1/2 times ERFC of EB upon 4 eta. In case of BPSK, it is 1/2 times ERFC of EB upon eta. Probability of error in case of BFSK, it is in between these two, that is 1/2 times ERFC of, that is complementary error function, ERFC of EB upon 2 eta. And this ERFC function is again a decreasing function of argument. That is, if this bracket term increases, then overall value of a complementary error function will be decreased. So the maximum value of probability of error will be in the case of ASK. As you see, the denominator is maximum in case of ASK. It means this argument is least in this case, and as the argument is minimum, so the value of error will be maximum in case of ASK. So what is the basic reasoning? Because it is ASK, out of all these techniques, only ASK is the linear modulation techniques in which information is carried in amplitude, and amplitudes has maximum effect of noise. Therefore, you can say that the ASK will be having maximum probability of error. Next. Which one of the following statements is correct? The equalizing pulses in TV transmission are sent during, you just have to remember that during vertical blanking. Equalizing pulses in TV transmission are transmitted during the vertical blanking. Next is, and this question is repeated so many times in different type of PSU's examination as well. So these type of questions you just have to remember. Next is, for a binary symmetric channel, which one of the following is the correct expression for entropy? So you know that entropy is given as summation I is equals to 1 to n, as many symbols are there, pi log 1 upon pi. So for binary symmetric channel, if probability of transmission of 1, let's say it is equals to p, then there are only two sources, two symbols. Therefore, probability of transmission of 0 will be 1 minus p. Therefore, entropy will be I is equals to 1 to 2 only, where there are only two symbols, and probabilities are pi log 1 upon pi, which is equals to, let's say it is p1 and it is p2. So it is going to be p1 log 1 upon p1 plus p2 log 1 upon p2. If you substitute the values, then it will be p log 1 upon p plus 1 minus p log, and all the logs are of base 2, so it is p log 1 upon p 1 minus p log 1 upon 1 minus p. And accordingly, if you see, So P log base 2 1 upon P plus 1 minus P log base 2 1 upon 1 minus P, that is option A is correct for this question. It is again a direct formula based question. Next, the channel capacity of a noiseless channel is equals to rate at which information is transmitted. Yes, channel capacity is what? Channel capacity is maximum data rate. Maximum data rate to maximum bit rate. So rate at which information is transmitted, sampling speed, bandwidth, and bandwidth SNR product. Out of these four, the most appropriate option is rate at which information is transmitted. And for noiseless channel, we have already mentioned it. That is, for noiseless channel, it is going to be what? 2b log base 2L. Next is match list 1 coding technique in digital communication systems with list 2 purpose and select the correct answer using the code given below the list. So what we are having here is, first one is Huffman code. So in this, in the list 2, we are having elimination of redundancy, adaptation, adapts the transmitted signal to the line, reduces the bit rate, and channel coding. So Huffman code is not a channel code. Huffman code and Shannon-Ferrand codes are source code. So what source code does primarily is, it eliminates redundancy, it compresses the signal and maximizes the data rate, data information rate. So accordingly, if you see, so Huffman code is a source coding which will eliminate the redundancy. Next is error correcting code. So channel coding is used for error coding, error correction and detection. So for B, you will be selecting 4. Next, NRZ coding. In NRZ coding, you can say that the values 0 and 1, it is non-return to 0 code. So it is a line coding. It is a line coding technique which maps 0 or 1 as a, you can say that NRZ coding, if you see the remaining options, reducing bit rates and adopts the transmitted signal to the line, it is the absolutely correct statement for NRZ coding, because in this line coding, we map the transmitted bit 0 to 1 onto the line. So adopts the transmitted signal to the line, it is correct for 3. And finally, delta modulation. In delta modulation, we are just encoding the difference of the signal. So you can say that it is reducing the bit rate. It reduces the bit rate, and accordingly for D, option 2 is correct. So if you see the matching, then for A, it should be 3. For A, it should be 3. Option B or D may be correct. For B, error correcting code, the value should be 4. So 3 and 4, and accordingly option B is correct. 3, 4, 1 and 2. For C, it is 1. Okay. For A, it is 1. So for A, it is 1 means A or D may be correct. And for B, it is 4. So for A is 1 and B is 4 means option C is correct for this question. So option C is correct for the given question. And moving to the next question, which one of the following is impulse response of a matched filter for a signal S of t of the type shown below? So it is very basic definition, that is, for matched filter, if S of t is a real signal, for real S of t, matched filter impulse response, matched filter impulse response H of t is given as Si of t minus t, or you can write it, that is nothing, it is nothing but Si of minus t plus t. So why match filter is used? It is used to maximize the signal to noise ratio at the receiver. So you just have to calculate this H of t, which will be the time delayed and reversed function of S of t. So for this S of t, if you find from this given S of t, if you plot S of t plus t, we are using this expression and we are applying the operations from right to left. So first, for given S of t, if we find S of t plus capital T, so this signal, if we advance it by plus t capital T seconds, then it will be moving towards left hand side by amount t. So this 0 point will come to the minus t seconds and it will look like this. It will be from minus t to 0 seconds. Value will be 1 as in this case. So we have obtained s of t plus t. Now we have to perform one more operation, that is we have to replace t by minus t, that is we have to take the time reversal of s of t plus t. So by replacing t by minus t, finally we'll be getting, if we plot here, s of minus t plus t. So if we apply time reversal on this, then what we just have to do is we just have to take the replica of this signal about y-axis. So this point will get to the other side and it will be looking like this. That is, it is going to be the value of s of minus t plus t. We just have folded this with respect to y-axis. So the folding of s of t plus t will result into this function with respect to t. So it is the impulse response of matched filter h of t, and if we compare with the given options, then from 0 to t value is 1 h of t. This option B is correct. So we just need to calculate the value of si of minus t plus t, and accordingly option B is correct. Moving to the next question. Which one of the following is the correct statement? If the channel bandwidth double, the SNR ratio becomes. SNR is what? S by N ratio. It means what? Signal power upon noise power. Noise power, this Pn, you know that it is proportional to KTB or eta B. KT is equals to eta. It means as the bandwidth increases, noise power increases. But as the bandwidth increases, signal power do not have any effect by increasing the bandwidth. Let's say you are having a spectrum of the signal which is lying from in the range, any particular range. So if you are either taking this much frequency or you are taking this much frequency range, the value of signal will be same in both the cases. But noise is present at every frequency with same probability. So if you are going to increase the bandwidth, then the noise passing through that bandwidth will be increasing. Therefore, the noise power will be increasing with getting increasing bandwidth. But the numerator signal power will be constant only. So if you are going to double the bandwidth, then signal to noise ratio will become halved, because the numerator will remain same, but the denominator will get doubled. Therefore, this overall ratio, signal to noise power ratio, will decrease by half. So if you see here, it remains same with increased bandwidth. But noise power gets doubled if bandwidth is doubled. Hence, the overall effect on signal to noise power ratio is, if you are going to increase bandwidth by 2 times, then SNR will get halved, and accordingly half of the former SNR ratio, option C, is correct. Next, a pulse radar is designed to detect objects up to 100 kilometers and the time base is 10 microseconds per kilometer. What is the maximum pulse repetition frequency? What we are having in this question is distance of target. Distance of target is what? 100 kilometers. And time base is what? 10 microseconds per kilometer. It means it takes 10 microseconds for a pulse to travel for a distance of 1 kilometer. So if you have to cover a distance of 100 kilometers, then how much time would you require? So the time required by the pulse to reach the target To cover a distance of 1 kilometer, the pulse takes 10 microseconds. So to cover a distance of 100 kilometer, how much time will be there? So it will be 10 microseconds per kilometer into 100 kilometers. That's why this kilometer will get cancelled, and you will be having the total unit in microsecond, which is the unit of time. So 100 into 10, that is equals to 1000 microseconds. 1000 microseconds time is required. So if 1000 microsecond time, therefore pulse repetition frequency, maximum pulse repetition frequency, is equals to 1 upon this value, that is 1 upon 1000 microseconds. Is it right? So it will be 10 to the power 6 upon 10 to the power 3, that is equals to 10 to the power 3, which is equals to 1000. And as it is the hertz frequency, so the unit will be hertz. And accordingly option B is correct. So we have given this case that the time base is 10 microsecond per kilometer. Total distance to be covered is 100 kilometers. So we have first calculated the time to reach the pulse to the target, and as it is the time, so we can use the maximum pulse repetition frequency, that is 1 upon this value, that is 1 upon 1000 microseconds, that is equals to 1000 hertz. Accordingly option B is correct. Next, we have to match list 1 with list 2. In list 1 we are having 3 modulation techniques, PSK, FM and AM, and list 2 we are having square law detector, matched filter and ratio detector. So whenever you are going to study any of the data transmission, bandpass data transmission techniques, ASK, FSK, PSK, MSK, QPSK, all of these uses matched filter to improve the signal to noise ratio. So PSK, you will be selecting matched filter. FM, you know that ratio detector is used for demodulation of FM. And next, AM has square law detectors. So accordingly the option is, for A there should be 3, for A there should be 3, for B there should be 2. Therefore option B is correct for this question. Next, which signaling scheme is most affected by noise? So we have already seen that all remaining these 3 are non-linear modulation techniques, in which information is carried either in phase or in frequency, which is less affected by the noise. But this technique is a linear modulation technique in which information is carried out in amplitude, which is badly affected by the noise process. So option A is correct. Which signaling scheme is most affected by the noise? Then it is ASK. Is it clear? Any doubt till now? Next is, a digital communication system uses 8 PSK modulation and transmits 3600 bits per second. What is the symbol rate? Again we are asked to find the symbol rate, that is baud rate. And we have already discussed that this baud rate is equals to bit rate divided by log base 2m. That is, bit rate means we have to find bits per second divided by bits per symbol. Then we'll be obtaining the value of ratio symbols per second. That is nothing but the symbol rate. So for 8 PSK, m is equals to 8, log base 2 m is equals to 3. So it is going to be bit rate, that is bit rate is given to be 3600 bits per second, and divided by log 2m is 3, therefore it is equals to 1200. It is 3 is symbols, bits per symbol. So it is going to be 1200 symbols per second. It is going to be the value of baud rate. Accordingly option D is correct. Next is, what is the main objective of trellis code? See, trellis coding, it combines the coding and modulation. And due to this combination, to have minimum error probability. And accordingly, to reduce the error rate, it must be the option. That is, and it combines the coding and modulation without increasing the bandwidth. One more thing is, without increasing bandwidth. So, to narrow the bandwidth is not correct. Narrow bandwidth is not getting reduced, it is maintained. To simplify modulation, no. There is modulation is already present, but we have combined coding with the modulation. Next is to increase the data rate. No, it is not used to increase the data rate, but primarily it is used that this combination coding and modulation is used to minimize the error probability, or you can say the minimize the error rate. Therefore, option D is correct for this question. Next is assertion is given as FSK signaling is inferior to PSK signaling. It is absolutely correct because we have already seen that probability of error in FSK is greater than probability of error in BPSK. Probability of error in PSK. We have mentioned here, if you see this, from this you can infer that probability of error in ASK is maximum. Probability of error in BPSK, if we are getting and taking the maximum, then first will be BFSK, and the least is in PSK, BPSK. So FSK is inferior to PSK because the probability of error is lesser in PSK. So you can say that we are on this question. FSK signaling is inferior to PSK signaling. It is absolutely correct. And why it is correct? Because in FSK probability of error is more than probability of error in case of PSK. Next is PSK requires less bandwidth than FSK. It is again correct. PSK requires less bandwidth than FSK. It is also correct, but it is not the correct reasoning of first statement. Why we prefer PSK signaling? Because the probability of error in case of PSK is minimum. If we compare both these two. So this statement reasoning is correct, but it is not correct reasoning of it. Not correct reason of it. So assertion and reason both are correct, but this reason is not the correct reasoning for given assertion. So when both the statements are correct, but reasoning is not proper reasoning of A, then you will be selecting option B. Both A and A are correct, but R is not the correct explanation of A. Next, QPSK modulation allows higher data rate than BPSK for the same bandwidth occupying. Yes, it is correct. If you see, QPSK modulation allows higher data rate than BPSK for the same bandwidth occupying is correct. In QPSK, you have 4 symbols. In BPSK, you have 2. So this statement is correct. If you see here, the reasoning, gray code is used for the 4 signals transmitted in QPSK. It is again correct. Why use gray code? Because all the 4 symbols differ by each other maximum by 1 bit only. So we use gray code. So both the statements are correct, but this reasoning is not the correct reasoning for assertion, and again therefore you will be selecting option B. It is this statement is correct, but it is not the reasoning, because that the gray code is being used in QPSK. That's why we are preferring QPSK over BPSK. It is not correct. So reasoning is correct, but this is not the correct reasoning for assertion. Therefore again you are going to select option B. Next is, which one of the following is not a part of typical TV receiver? What we are talking about is TV receiver. So sweep signal generator, envelope detector, video amplifier, and if you see here, pre-emphasis circuit, and in both the sessions we have already conducted two sessions. In on both those sessions we have discussed that this pre-emphasis circuit is always used at the transmission end, used at transmitter end. At receiver end we use de-emphasis circuit. Therefore this is the correct option. Which is not being used, which is not a part of TV transmitter, that is pre-emphasis circuit. Next, is which one of the following statement is incorrect about the matched filter? Which one is incorrect about the matched filter? The maximum output SNR depends on input signal energy. It is absolutely correct. It is correct. We have to select the incorrect statement. So SNR depends on input signal energy. SNR is signal to noise power ratio. So if signal energy will be increased, then definitely the signal to noise ratio will get increased. Second one is the impulse response is reverse delayed version of the input signal. We have already seen that h of t is equals to s of minus t plus t. That is, it is a reverse delayed version of the input signal. It is a correct statement. Next statement is the error probability depends on the wave shape of the signal. This statement is not correct. The error probability depends on energy of the signal, but not on the shape of the signal. If we have to check, the error probability depends on the wave shape of the signal. It is independent of the shape of the signal, but it depends on the energy of the signal. So this statement is not correct. Depends on signal energy, not on shape. So this statement is wrong. Next statement, if you see, matched filter and correlated gives identical reception performances. So it is again a correct statement, because either you use matched filter or correlator, both the systems are used to maximize signal to noise ratio at the receiver end. So this statement is again a correct statement. So if we have to select the incorrect statement about matched filter, then we are going to select option C. The error probability depends on the wave shape of the signal is not correct. Moving to the next question. Match list 1 with list 2. In list 1 we have some coding techniques, and in list 2 we have their impacts. So if you see here, source encoder. Again, what we have discussed is source coding, in which Shannon-Fano codes or Huffman codes are involved. These codings are to eliminate redundancy, that is to compress the data and to maximize the information rate. So for source encoder, you will be selecting maximization of information transmitted. Next is channel encoder. So channel encoder, you know that channel encoder is used to add some parity bits for you can say the error detection and correction processes. So as you are able to correct or detect error, it means you are protecting your message using the channel coding. So channel encoder is used for the protection of message. Next is line encoder and equalizer. So equalizer, you know that equalizer is used to reduce inter-symbol interference. And next is line encoder. So for line encoder, you will be selecting synchronization. Accordingly, the options should be in the manner of 4, 3, 2 and 1. 4, 3, if you see, none of the options are correct. Either there is any misprint. So it should be 4, 3, 2 and 1. 4, 3, 2 and 1. Then this option C is correct, because we have matched absolutely correctly. That is, source encoder maximizes information transmitted, channel encoder message protection, line encoder synchronization, and equalizer will provide will reduce the inter-symbol interference. Accordingly, option C is correct, but there is a misprint in option C. Next, question number 42. If the probability of a message is 1/4, then the information in bits is. So information is equals to directly, you know that it is inversely proportional to the probability of signal. A message with least information will have maximum, least probability will have maximum information. So I is equals to log, and if you have to calculate in bits, then you are going to take log base 2, 1 upon t. If you take the base n equals to base e, then the information unit will be nats. So there are several other units. If you have to calculate in bits, then you will be taking log base 2. So it is going to be log base 2 1 by 1 by 4, that is equals to 4. So it is going to be what? 2 bits. And accordingly option B is correct for this question. Next is MSK, minimum shift keying, is an orthogonal FSK scheme that gets its name from the fact that the phase shift is minimum, the error probability is minimum, the transmission power required is minimum, and the transmission bandwidth required is minimum. If you see, then the basic reasoning is condition of orthogonality. Zero to TB. First we have I am just writing achieved. Condition of orthogonality is achieved for minimum value of n, where but if we have to select from the options, what does it mean? That is, minimum shift keying gets its name from the fact that the phase shift is minimum in this case. So we are going to select the option A, that is the phase shift is minimum, but the actual condition is the condition of orthogonality is achieved for minimum value of n, where n is what? Omega h minus omega l, the maximum frequency C. This MSK, minimum phase shift gain, it is the combination of MSK is combination of QPSK and BFSK, or you can simply write it is combination of PSK and FSK. For FSK, you transmit symbols of two different frequencies, one higher frequency, one lower frequency. So the difference of these frequencies n into omega c, so the value of n that satisfies the condition of orthogonality, for MSK that condition is satisfied for the minimum value of n, that is equals to 1. Therefore we name it as minimum phase shift keying. And if you compare, then this option, the phase shift is minimum, is the correct option for this given question. Accordingly you are going to select option A. Next is frequency fogging is used in carrier system to reduce crosstalk. You just have to remember, that is, we have already discussed what the crosstalk is. It is the interference between adjacent channels, and frequency fogging is used to reduce that interference. Therefore frequency fogging is used to reduce crosstalk in the carrier systems. The power gain of an antenna using paraboloid reflector is directly proportional to, if you see power gain, then it is given as eta times pi d upon lambda whole square. Sometimes you take this value, that is equals to eta and pi square multiplied, it is equals to 9.81 as well. Or in more general, if you see, gain is proportional to d upon lambda whole square. If efficiency and pi are considered to be constant factors, so gain G is d upon proportional to d upon lambda whole square. And if you take it as aperture ratio, then square of the aperture ratio is correct for this question. That is, gain of antenna of parabolic reflector is proportional to the square of aperture ratio. Next is the secondary TDM level provides 24 channels in ME-law system and 30 channels for A-law system. See, mu-law systems, these are used in North America and Japan. These are also known as T1 systems. A-law used in Europe and other regions. And these are also named as E1 systems. So primary TDM system, it uses 24 channels in mu law and 30 channels in A law. That is 24 channel in T1 system, 30 channel in E1 system. But as we have asked secondary TDM, so secondary TDM, it uses 24 into 4, that is 24 into 4, that is 96 channels in mu law and 30 into 4, that is 120 channels in A law. So you just have to remember these factual questions, factual data, that is 96 and 120, and accordingly option C is correct for this question. For secondary TDM, it is the data that you have to remember. Next is the correct sequence of operations which a regenerative repeater performs is. So I have just taken an image for you as well. That is, it is the block diagram of regenerative repeater. First we have amplifier or equalizer, then timing circuit is used, then decision making device is coming. So the correct sequence is equalizer, then timing circuit, and then decision making device. Equalization, timing, information, then decision making. Therefore option B is correct for this question, right? Next is a conventional telephone line with 3 kilohertz bandwidth and having 30 dB signal to noise ratio can carry information at a rate. So you just have to information rate. Maximum information rate is known as channel capacity, and you know that channel capacity C is equals to B log base 2 1 plus S by N. So you are having S by N ratio in dB is equals to 30 dB. In dB you can take 10 log base 10 S by N, it is equals to 30. You can cancel this 30 by 10 and you will be having 3. Therefore absolute value of S by N ratio is going to be base 10 to the power, we are having 3 here, 10 to 3 times, so it will be 10 to the power 3. So SNR ratio actual value we have obtained as 10 to the power 3, which is very much greater than 1, so you can neglect 1. Now what you have given is conventional telephone line has 3 kilohertz bandwidth. Bandwidth is given to be 3 into 10 to the power 3, and we have to evaluate the value of log base 2 1 plus S by N. S by N is 1000, so okay, we are taking 1001. So to find value of 1001 for the base 2, you can find it like 3 into 10 to the power 3 into, if you calculate log base 10 1001 and divide it by log base 10 2, then you will be having the value of log base 2 1001, and it is going to be 3 into 10 to the power 3 into, if you take in log base 10, the value of 1001 will be, if we calculate log 1001, so it is 3.000, that is 3 divided by log base 10 2 is 0.301, so it is equals to 10. So now it is equals to 10 into 3 into 10 to the power 4, that is 30 into 10 to the power 3, and accordingly that is bits per second. So accordingly option 30 kbps is correct option. So option A is correct for this question. Next is which one of the following satellite system is most often used for global positioning system? So you are having different options, but for GPS you must be knowing that we use MEO satellites, that is medium earth orbit. It is used for GPS system. For GEO, LEO, MEO, you must be knowing the altitude levels. This geosynchronous orbit is situated at 36,786 kilometer. This lower earth orbit LEO, it is in between 200 to 2000 kilometers. Altitude level I am talking about, not it is geostationary. For geostationary it is 36,786. Geosynchronous, it is also at the same height but with different inclinations. And medium earth orbit, it lies between 2000 kilometer and 36,786 kilometers. So for global positioning systems, GPS satellites are used. GPS satellites uses medium earth orbit, that is MEO. So option D is correct for this question. Next is, a frequency division multiplexing system is used to multiplex 24 independent voice signals. Single sideband modulation is used for the transmission. Each voice signal is allotted a bandwidth of 4 kHz. What is the overall transmission bandwidth of the channel? So if FDM is used, then if you are having 24 voice channels and each channel is having 4 kHz bandwidth, then total bandwidth, if there is not mentioned the value of guard band, if you are not using any guard band, so you just have to take the product of these two, that is how many number of channels are there and how much bandwidth a particular channel is taking. So overall bandwidth will be 24 into 4 kHz, that is equals to 96 kHz. If there would be guard band, so with guard band, total bandwidth is n into FM plus n minus 1 into guard band, F guard band. But if there is no guard band, then only n into FM, that is total number of voice channels into bandwidth of each voice channel, is going to be the total bandwidth requirement for this FDM system. Next is, a time division multiplexing system is used to multiplex 4 independent. Okay, it is a different question. Yes. So it is given as, it is using 4 independent voice signals using pulse amplitude modulation. Each voice signal is sampled at a rate of 8 kHz. The system incorporates a synchronizing pulse train for its proper operation. What is the timing between the synchronizing pulse trains and the impulse trains used to sample the 4 signals? What we are having is, each voice signal is sampled at a rate of 8 kHz. So if we are having sampling frequency, that is frame rate, you can also say rate of sampling or frame rate, that is equals to 8 kHz. Therefore, sampling interval or frame duration, you can say, that is equals to 1 upon Fs, that is equals to 1 upon 8 into 10 to the power 3, that is equals to 125 into 10 to the power minus 6, that is 125 microseconds. So we are having a total time of 125 microseconds in which we have to transmit the data from 4 independent voice channels, 4 independent voice signals, and we are also having one synchronization pulse. So the total pulses is equals to 4 signal pulses plus 1 synchronization, that is equals to 5, and total time duration available is equals to 125 microseconds. Therefore, spacing is equals to 125 microseconds divided by 5, that is equals to 25 microseconds. These type of questions are simplified using the same result that I have taken in this question, and we have taken similar question in the last session as well. So whenever you are having this type of question, what you have just to do is, you are having sampling frequency, just calculate the value of sampling interval, see how many pulses are there, total pulses including in synchronization pulse. So total number of pulses you will be having, and then you are having the total interval what is available for the transmission of those 5 pulses. So just to find the spacing, what is the timing between, or you can say spacing. So the timing between the synchronization pulse train and the impulse train used for sample 4 signal is directly the ratio of total available time upon total number of pulses, that is equals to 25 microsecond, and accordingly option D is correct. Accordingly option D is correct. Next is, what is the spectral efficiency of 16 QM? This spectral efficiency rho is given as bit rate upon bandwidth, and bandwidth for M-array QM system is 1 upon TB log 2M, and this 1 upon TB, it can be written as RB, that is RB upon log base 2M. So spectral efficiency is RB upon log base 2M, where M is equals to 16. If we are considering 16 QM, then M is equals to 16. So it is going to be RB and RB will get cancelled, and you will be having log base 2M, that is log base 2 16, that is equals to 4. Therefore 4 bits per second per hertz, that is option D is correct for this particular question. The value of bandwidth for different cases are different. Like for PSK it is some other value, for BPSK, for FSK these are different values. But for QM you can use 1 upon TB log 2M, that is RB upon log 2M. Next is, a discrete source emits one of 5 symbols once every milliseconds with probabilities 1 by 2, 1 by 4, 1 by 8, 1 by 16 and 1 by 16 respectively. What is the source entropy? So we have just written the formula in previous question, that is entropy H of X is summation from I is equals to 1 to n, how many symbols are there, and Pi log 1 upon Pi. So for this question, what we are having 5 symbols, and probabilities are given as P1 is 1 by 2, P2 is 1 by 4. So if we just have to calculate the entropy, then we can take in any order the values of probability. But if we would be calculating, if we would be designing either Huffman coding or Shannon-Fenner coding, so for source coding techniques, first we arrange these probabilities in ascending order. So as we are just trying to calculate the entropy, then the order is not important. So we are taking in the given sequence as well only. So it is P1 is 1 by 2, P2 is 1 by 4, P3 1 by 8, P4 1 by 16, P5 1 by 16. If we substitute the values, then it is going to be P1, that is 1 by 2 log base 2, 1 upon 1 by 2 will give 2, plus 1 by 4 log base 2, 1 upon 1 by 4 will be 4, plus 1 by 8 log base 2 8, and plus 1 by 16 log base 2 1 upon 1 by 16, that will be 16, and 1 by 16 again log base 2 1 upon 1 by 16, that is 16. So if we calculate further, then it will be 1 by 2 times log base 2 into 2 is value is 1, plus 1 by 4 into log base 2 4 is 2, plus 1 by 8 log base to 8 is 3 plus 1 by 16 log base to 16 is 4. So 1 by 16 into 4 and plus again it is the same value 1 by 16 into 4. So overall what we are having is 1 by 2 plus 1 by 2 plus 3 by 8 plus 1 by 4 and 1 by 4. So the total LCM we can take as 8 and it will be 4 plus 4 plus 3 plus 2 plus 2, which is equals to 4 plus 4 8 plus 3 11 plus 4 15 by 8 is equals to 1.875, and bits per symbol is the unit for entropy, so it will be bits per symbol, and accordingly option B is correct. 1.875 bits per symbol is the correct one. Okay, so this was the last question and we have solved 53 questions in this session. So if you are having doubt in any of the question, then please let me know. 35 786. Okay, what I have written here, 36. No, yes, it is 35 786. This is absolutely correct. 35 786 in both cases you can write is correct. 35,786 kilometers is correct. Good. So we have taken 3 sessions for communication PYQs of ESE and 2 sessions for signals and system PYQs. So you must be getting benefit of these sessions. If you are having any other queries, then you can comment in the comment section. और जो भी लोग हैं जो कनेक्टेड हैं, आप लोग दूसरे सब्जेक्ट के लिए बताइएगा, जैसे कंट्रोल सिस्टम का भी हम प्लान कर रहे थे कि ऐसी PYQs करें हम यहाँ पर। तो अगर आप लोग चाहते हैं कि कंट्रोल सिस्टम के PYQs भी हम करें तो उसको आप कमेंट सेक्शन में बताइएगा। और बार बार मैंने ये कहा आपसे कि ये ESE में जितने भी आपके क्वेश्चंस आने वाले हैं, जो इस बार आप अपीयर होंगे 2025 ESE में, आप देखेंगे कि प्रीवियस ईयर क्वेश्चंस में से 40% से ज़्यादा क्वेश्चंस एज इट इज़ रिपीट होने वाले। इसीलिए आपको इन PYQs को इतना इंपॉर्टेंस देना पड़ेगा कि इसको एक बार नहीं, 2 बार नहीं, कम से कम 4 से 5 बार हर क्वेश्चन को आपको करना है, कि अगर ये रिपीटेड क्वेश्चंस आते तो इसमें आपका टाइम ना जाए। जैसे ही आपने टाइम देखा, मतलब क्वेश्चन देखा, वैसे ही आप तुरंत उस ऑप्शन को आप मार्क करें। ठीक है, तो ये बहुत ही ज़्यादा ज़रूरी है। ESE की जो प्रिपरेशन है वो बिना PYQ के, मतलब आप समझिए कि कुछ प्रिपरेशन, आप जो मेन प्रिपरेशन है वो सिर्फ और सिर्फ PYQ की प्रिपरेशन है। अगर किसी ने बहुत अच्छे से PYQ किया है तो बाकी और किसी भी सोर्स के वो ESE प्री बिल्कुल आप उसको क्वालिफाई कर सकते हैं। ठीक है, तो यहाँ तक समझ पा रहे हैं सभी लोग? PDF आपको मैं शेयर कर दूंगा, मतलब सर को मैं शेयर कर दूंगा, वो जो ऐप का जो फ्री डाउनलोड सेक्शन है वहाँ पर आपको PDF मिल जाएगा, वहाँ से आप इसको डाउनलोड कर सकते हैं। तो चलिए फिर आज का सेशन एंड करेंगे और इसके बाद देखते हैं फिर कंट्रोल सिस्टम के अगर PYQs की रिक्वायरमेंट होगी आप लोगों को तो कंट्रोल सिस्टम के PYQs भी हम यहाँ पर लेकर आएंगे। ठीक है, फिर सेशन एंड करें आज का। चलिए फिर ठीक है, मिलते हैं नेक्स्ट सेशन में। तब तक के लिए थैंक यू सो मच, ऑल द बेस्ट, टेक केयर, बाय बाय।